So as you already know, electricity is an incredibly integral part of your life and our society. So what is it, and where does it come from? In order to understand electricity, we're going to have to start small, at the atom in fact. You see, electricity is all about atomic particles, particularly the electrons. So let's start with a quick reminder about our atomic model. We have a central nucleus made up of protons and neutrons. And then around the outside, we have a cloud of electrons. And we'll show them as little particles moving around in orbits, as this is a nice model of our atom. Now, most interesting to us as we study electricity are the charged particles. That is, the protons have a positive charge, and the electrons have a negative charge. And we'll just ignore the neutrons for now, as they have no charge. Now, the protons and electrons have the same amount of charge. We call it the elemental charge. But they each act differently. So we call a proton positive and an electron negative. A proton and an electron together will cancel each other out for a net charge of 0. So, an atom that has the same number of protons and electrons would be considered to be overall neutral. That is, it has no charge. If the atom loses some of its electrons, well, then it would have a positive charge, more positives than negatives, and we'd call this atom a positive ion. Ion just meaning it's not neutral. In the same way, if an atom has some extra electrons in its electron cloud, we would call it a negative ion. Again, ion meaning it's not neutral, and negative indicating that there are more electrons than protons. Notice that we keep talking about the atom losing or gaining electrons. Well, what about the protons? Well, the protons are part of the nucleus, and that means that they're kind of locked into place. The electrons are the particles that are free to move around a lot more. In some materials, the electrons can move around a little bit, while in others, the electrons are flowing all over the place. So, we've hit the first big idea. When it comes to understanding the nature of electricity, it all has to do with charged particles within the atoms. The second big idea has to do with the forces between charged particles. Just like the moon is attracted to the Earth due to gravity, electrons are attracted to protons. Instead of gravity causing the force this time, the force is called an electrostatic force. Just like we can calculate and predict forces of gravity, thanks in part to Isaac Newton, we can also calculate and predict electrostatic forces, thanks in part to Charles Coulomb. Protons and electrons attracting each other like gravity is fairly easy to visualize. Here's the part where it gets a little more difficult to find a common analogy. Like charges repel each other. For example, two electrons are pushed away from each other. They repel each other. In the same way, two protons push away from each other, or repel each other. So, unlike charges attract, but like charges repel. Learning how to take advantage of these forces is core to all the electrical devices you see around you. In this tutorial, we looked at the source of electricity. We found that we had to look within the atom to find our source. Within the atom, we found protons and electrons. Protons are positively charged, electrons are negatively charged. We also discovered that there are forces between these charged particles, and we call them electrostatic forces. And they cause unlike charges to attract each other and like charges to repel each other. Understanding these core principles will allow us to build a solid knowledge about electrical phenomenon and electrical devices.